The steel production process is strictly controlled and carried out in a scientific and modern way. After being selected, iron ore will be fed into the blast furnace with coke and limestone to create molten pig iron, the first and key stage in the production chain. Next, pig iron is transferred to the blowing oxygen furnace, where the decarbonization process takes place, the main steelmaking step that helps control the chemical composition. The molten steel is then continuously cast into billets before undergoing pressure processing stages such as hot rolling, cold rolling, or galvanizing. Each stage is monitored with advanced technology to ensure high precision and quality. The entire process ensures outstanding production efficiency, contributing to the creation of reliable steel products for key industries. The loop ties machine is an automatic device that specializes in producing all kinds of steel wire details used in construction from single coils. The machine can change size automatically in just 2 minutes, with a capacity of 1,200 to 1,600 products per hour depending on the model. The machine configuration is sturdy, compact, easy to install accessories for each different type of detail. Simple operation, suitable for all workers, almost no maintenance required. The machine can produce steel chairs from 6 to 78 inches and meets CE, UL, and CSA standards. The steel pipe manufacturing process in Huhtamaki includes steps such as steel smelting, billet casting, mechanical processing, and steel pipe production. This process combines modern technology and technical expertise to create high-quality steel products that meet strict technical requirements. Bozdemir baseline offers connectable reel diameters of U 560 mm and U 630 mm for rigidity, meeting DIN 46397 standards. The product uses a stable synchronous gear and rotation drive system, ensuring stable operation and high synchronization. With its flexibility and the ability to be customized according to customer requirements, Bozdemir baseline ensures outstanding performance in energy production. Applying modern production lines to produce steel rails up to 120 meters long. The process starts from melting steel, casting billets. Then the billets are heated to about 1,200 degrees Celsius before rolling. The hot rolling process shapes the rails to standard sizes, combined with cleaning, cooling, and quality control. The synchronized control system helps ensure straight, even rails. Finally, the products are non-destructively tested to ensure they meet the high technical requirements of the railway industry. The production process of tubes by the Formadora de Tubos Zucchelli machine starts with the standard of the steel coil, quality control, and loading into the coiler for continuous material supply. The steel is produced according to the Endurador machine standards with hyperbolico coil products, ensuring the surface before entering the forming step. At the Formadora machine, the steel is gradually passed through the roller stations, sealed with high-frequency welding technology or TIG-MIG, then refined to achieve the size and roundness accuracy. The tube is then automatically cut into required sections, quality control of welds, dimensions, and strength, before surface treatment and packaging for delivery, ensuring high performance and standard products. The Okuma MULT USB 252 is a multifunctional CNC lathe designed to reduce setup times by eliminating repetitive fixture changes, improving precision, and minimizing non-cutting time. Equipped with AR/MROID technology, this machine can perform tasks previously done by humans, enhancing overall productivity. It offers a seamless integration into future manufacturing systems by automating processes and optimizing efficiency. The MULT USB 252 is ideal for complex machining tasks, offering high versatility, precision, and reduced operational costs, making it a key factor in advanced manufacturing environments. It ensures maximum output with minimal human intervention. IML Design specializes in providing high-precision metalworking solutions with modern technology, such as cutting disc and metal spinning. The cutting disc process helps create precise details and sharp cuts on many different types of metals. Meanwhile, metal spinning technology is applied to create round, symmetrical metal products, ideal for details such as lampshades, machine covers, or industrial parts. IML Design is committed to providing high quality, durability, and aesthetics. The DBR 700-2000's automatic lathe from Rottler Maschinenbau is specialized in machining aluminum round bars with diameters up to 700 mm and lengths of 2,000 mm. The machine is equipped with a comprehensive automatic pre- and post-processing system. As a compact CNC machining center, the DBR 700-2000s delivers high performance and outstanding precision. The hot-dip galvanizing process at Marmara-Signer Galvaniz begins with receiving and inspecting the product, followed by chemical cleaning to remove grease and rust. The product is flux-coated and galvanized in a zinc alloy bath at 450 degrees Celsius. After plating, the product is cooled and quality checked before packaging and shipping. This process protects the product from corrosion and extends the life of the steel. The PFM 137 gantry milling machine is a powerful machine, ideal for large-scale machining applications. With a long table design of up to 25,000 millimeters and a drive power of 137 kilowatts, the machine is suitable for machining parts such as rails, switches, and intersections from high-strength materials. Equipped with a modern Cinumeric 840 DSL CNC control, the machine allows precise and efficient operation. The spindle uses the SK60 tool holder, combined with an automatic head angle changer system, which increases flexibility and reduces setup times. Okuma Multis U3000 is a multi-function milling lathe, featuring the ability to flexibly process complex parts. The machine is equipped with a powerful high-speed spindle and a precise CNC control system. This technology allows precise gear machining, increasing productivity and improving surface finish, meeting the strict requirements in mechanical manufacturing. The Vanek America and Trantec Automation automated system uses 9 Fanuc robots to hang, wash, and coat steel I-beams. The process begins with the robots using industrial magnets to lift the beams, separate them, and place them on a conveyor. The beams are transferred through the washing, coating, and return systems for automated stacking. The manufacturing process of combi-ware parts includes design, custom molding, machining, quality control, grinding, assembly, protective coating, and final inspection before delivery. The Wortman separation system consists of three state-of-the-art machines: the VB1050 jigsaw, the V630M 3-axis drilling machine with automatic tool changer, and the V808M 8-axis cutting machine. All machines are seamlessly connected to the industry's only intelligent conveyor system, which enables efficient and precise handling of steel components. Thanks to its high level of automation, the system only requires 2 operators and a forklift driver to ensure the entire line runs smoothly. This solution not only increases productivity, reduces labor costs, but also optimizes production times for steel fabrication companies. The process of producing steel from raw materials is one of the environmentally friendly and energy-saving methods in the modern metallurgical industry. First, steel is collected from many sources such as old cars, industrial equipment, clearance works, and manufactured products. Then, the raw materials are sorted, impurities are removed, and put into the electric arc furnace, EAF. Here, the extremely high temperature generated by the arc will heat the raw materials into intact steel at 1,600 degrees. Next, the smelted steel will be refined to adjust the chemical composition, remove sulfur and phosphorus, and ensure the quality meets the standards. Then, the steel is cast into bars or semi-finished products, such as bars, plates, and coils. Finally, the products are cooled, quality checked, and put into the next technology or distributed to the market. This process is both efficient and useful for renewable resources. The rapid production and installation of steel profiles at SteelCon begins with the collection of technical requirements and the design of steel profiles such as cranes, exhaust gas treatment systems, and industrial components. The steel materials are then prepared and processed through cutting, drilling, boring, and welding using modern machinery. The steel components are assembled and inspected for technical quality before being transported to the construction site. Here, the profiles are installed according to the design, including bridge systems, overpasses, thresholds, and loading equipment. This process ensures precision and stability for larger jobs. Rigid Strander Line EU630 with -630 rupees is a high-speed rigid stranding line for the production of copper and aluminum wires. The machine is designed to braid multiple coils of copper and aluminum wire at the same time, creating wire structures with different strand counts, including 19, 37, 61, and 91 strands. The spool diameter can be varied from 315 mm to 630 mm, suitable for applications requiring high flexibility in cable production. The -630 rupees has a double-sided rotating chamber that holds the coils independently, with versions that can accommodate from 6 to 30 coils. The wire braiding process is automatically controlled at a safe linear speed, minimizing errors and increasing efficiency. The machine can perform copper and aluminum bending in concentric, circular, compression, or fan-shaped shapes. In addition, the armoring and shielding system is also integrated to enhance the durability of the wire. The machine's automatic and semi-automatic feeding system saves the time of wire winding processing, enhancing productivity and production efficiency in the cable industry. The Reichel and Nadler portal milling machine was completely refurbished. The spindle, drive, guides, hydraulics, and electrical systems were all overhauled, and a sinumeric 840 DCNC was integrated. After geometrical correction, the machine was ready for precise operation. The Okuma MU8000V-L 5-axis machining center is designed for high precision and efficiency. It features a zero-point setting and part alignment with a touch probe for accurate positioning. The machine supports adaptive turn milling, ensuring optimal cutting conditions. It also includes tool breakage detection by laser for milling tools, enhancing reliability and safety. The outside surface finishing is achieved through turning, and the conical barrel tool provides improved performance for specific tasks, offering versatility and precision for complex parts. This makes the MU8000VL ideal for demanding machining applications. Steel is an alloy mainly of iron and carbon, widely used in construction and manufacturing. The wind turbine manufacturing process includes design, blade fabrication, shaft and housing, casting and machining, gearbox and generator assembly, quality inspection, protective coating, then transportation and installation at site. The manufacturing process of combiware parts includes the following steps: product design and development, precision casting and machining, rigorous quality control, product assembly and finishing, along with protective coating. Finally, the product is delivered and supported to customers worldwide. Okuma MULTUSU 3002 SW 1500 multifunction machine with spindle speed up to 1271 minutes supports effective B-axis turning. The machine is equipped with a roundness, diameter, and taper angle measuring system, helping to ensure high precision in machining complex parts, improving productivity and product quality. Hot-dip galvanizing is a process that protects steel from corrosion, a common problem when exposed to the environment. The process involves three main steps: surface preparation, galvanizing, and quality control. First, the steel is cleaned to remove grease and impurities, then dipped into a bath of molten zinc, where a chemical reaction occurs, forming a zinc-iron alloy layer that protects the steel surface. This coating helps the steel resist corrosion and prolongs the life of the product. Galvanizing not only reduces maintenance costs, but also protects the environment, thanks to the 100% recyclability of zinc, making the process sustainable and efficient. The anodizing process for T66061 aluminum and Ti6 Al 4 volts titanium begins with immersing the material in an electrolyte solution to create an oxide layer on the surface. First, the material is washed to remove impurities. Then, the material is immersed in an acid solution to allow the anodizing process to occur, creating a protective oxide layer. Next, the anodized layer is sealed with a special solution to enhance corrosion resistance and increase surface durability. After sealing, the material is completely dried. Finally, the product is thoroughly inspected to ensure that it meets the required quality standards, such as oxide layer thickness and coating durability. This anodizing process results in a durable and weather-resistant coating, suitable for adjustable camber plates used in high-tech applications. The Climax CM6200 portable circular milling machine is designed for machining large components, especially flanges with diameters from D1900mm to D7200mm. The machine is capable of high-precision machining and has a wide travel range. The Climax CM6200 is equipped with a CNC control system that performs machining operations automatically and accurately. The machine's motor has a powerful capacity, providing enough power to process hard and complex materials. The machine can process parts up to 12 tons in weight, saving time and transportation costs, while ensuring superior machining quality. The EstGal 2018 automatic hot dip galvanizing system at Uresa Galvaniz, Ankara, is a state-of-the-art technology designed to galvanize steel products, ensuring high durability and superior corrosion resistance. The system uses a galvanizing tank measuring 1.8 x 13 x 3.5 meters, which can handle large-sized steel products. The galvanizing process begins with cleaning the steel surface, removing impurities, grease, and rust. The product is then immersed in a hot-dip galvanizing tank, where the steel is coated with a protective layer of zinc. This zinc layer forms alloys with iron, providing long-term corrosion resistance and increasing the strength of the steel. Finally, the product is dried and quality checked before being finished. EstGal 2018 ensures high production efficiency and environmental protection, while reducing maintenance costs for steel structures used in many industries. Hot dip galvanizing is an aesthetic and durable process that protects metals from rust. It enhances the appearance of trendy materials such as wood, concrete, and metal, providing long-lasting protection. The process begins with quality inspection of the parts, followed by chemical preparation before dipping them into a bath of molten zinc at 450 degrees Celsius. After cooling, the parts are inspected and, if necessary, polished. Galvanizing is followed by thickness and adhesion testing to ensure quality. Additional options for painting or powder coating provide an aesthetic and corrosion-resistant finish to the customer's preference. The 4-roll hydraulic sheet bending press is an advanced machine designed for high-quality sheet metal bending, with a bending range of 2 mm to 200 mm in thickness and widths, from 500 mm to 12,000 mm. These presses are used in a variety of industries, especially those that require large-scale, precise sheet metal bending, such as construction, automotive, and heavy manufacturing. These machines are capable of bending sheet metal with exceptional precision, ensuring consistent results and meeting high industry standards. The machine frame is made from welded Street 52 steel construction, providing strength and durability. This robust design ensures that the machine can withstand high pressures and heavy workloads for long periods of time, making it a reliable tool for large-scale production. All components, including rollers, bearings, and other materials used in the manufacturing process, are sourced to meet European quality standards. This commitment to high-quality materials ensures long-lasting performance and minimal wear, reducing downtime and increasing productivity. One of the most important advantages of the 4-roll hydraulic sheet bender is its high torque capability. This high torque allows the machine to bend thicker materials and handle difficult tasks with ease, making it extremely versatile and efficient in a variety of bending applications. The machine also uses the lever principle in the guide system, which increases the bending capacity. This feature is especially valuable when it comes to pre-bending, as it ensures the process is carried out with greater precision. As a result, flat ends are minimized, resulting in better, more uniform bending. In addition to the mechanical features, the machine is equipped with an optional CNC, computer numerical control, system and controller, providing precise control over the entire bending process. CNC systems allow operators to input precise specifications, ensuring the machine consistently delivers high-quality results. With CNC technology, machine operations become more automated, reducing human error and increasing production efficiency. Operators can quickly set and adjust bending parameters, significantly reducing setup times and increasing throughput. The high level of automation of the system not only improves efficiency, but also ensures that products are bent to exact specifications with consistent accuracy. This capability is especially important when working with large batches of metal components or producing items that require high precision, such as cylindrical tubes, conical tubes, or custom-shaped parts. The bending process achieved with a 4-axis hydraulic machine is smooth and tightly controlled, resulting in high-quality end products. The 4-roll hydraulic plate bending press is also known for its ability to bend large sheets of metal with ease, even those in coil form. This feature allows manufacturers to work with large quantities of metal without worrying about size limitations. Additionally, the machine is well suited to a wide range of materials, including steel, aluminum, and stainless steel, adding to the versatility of the machine. The Nargesa MC150B tube bender is a reliable solution for bending a wide range of metal pipes and bars with high precision. For flat bending of platina, use rollers 3 and CCO, add washer 2 and tighten with nut 1. Lower the upper lever to lightly touch the material, operate the machine to the right and then to the left, repeat until the desired curvature is achieved. For edge bending of platina, simply adjust the distance between the rollers. When bending square or rectangular bars, use rollers 4 and C. Gently tighten the nut so as not to deform the material. For round pipes, do the same as for square bars. For square or rectangular pipes, combine rollers C and 4. Do not tighten the nut with a wrench, because the material may expand when bent. For T or L bending, install the rollers in the correct direction. Use additional side adjustment rollers to keep the material straight. For special materials such as stainless steel, aluminum or copper, Cestarin rollers should be used to avoid damaging the surface. Nargesa also offers 58 HRC hardened steel rollers for small metal pipes, ensuring high precision and long-term durability. The Spitfire nose cone for the restoration project was created using the metal spinning technique. For this we used 3 mm thick aluminum. Since this is a one-off product, we reduced machining costs by utilizing wood as a form. The metal spinning process involves mounting a sheet of metal onto a rotating mandrel and applying pressure with a spinning tool to shape the material. The metal is gradually formed as it spins, ensuring precise and smooth curves. Once the shape is formed, the piece is trimmed and finished to meet the required specifications. This method not only ensures high quality but also lowers production costs, making it ideal for custom projects like the Spitfire restoration. The wire rod preparation process begins with cutting and preparing the required iron rings. The iron rings are inserted using a stamp, then a press is used to press the iron rings together, ensuring they are tight and precise. Next, the iron rings will be secured with wire or other methods to ensure they do not move. Finally, the iron blocks need to be transported to another location, ready for the next steps in the product. The Nargisa MC650 tube bending and forming machine is a new machine specially designed for large-scale production, with a control system that allows the position of the rollers to be saved for each bend. This allows the machine to repeat identical operations without the need for longitudinal positioning control. The machine is ideal for the production of items such as flanges, greenhouses, railings, and large-scale construction projects. The maximum bending capacity for round pipes is 4 inches, 101.6 millimeters. The MC650 is made from welded and machined steel plates, making it extremely rigid and stable, ensuring high precision. The machine is perfect for the production of various structural components, such as round beams for roofs, canopies, bridge piers, metal trusses, curved tents, and tunnel structures. In addition, the machine is used to create urban furniture such as streetlights, roundabout guards, bicycle racks, tree guards, public transport tents, bollards, and playground equipment. Flexibility, power, and 4.0 technology integration make the MC650 the ideal tube bender for any company and is highly appreciated by customers for its adaptability. The MC650 complies with CE industrial machinery manufacturing standards, ensuring top quality and safety for industrial use. Ringcase sheet metalworking machines are commonly used for tasks such as cutting, punching, folding, and folding. They become essential for producing parts such as panels, frames, and enclosures. These machines are known for their high precision, durability, and operability, helping operators achieve precise results while maximizing productivity. The Plegadora de Chapa 2140/17AL is a professional sheet metal bending machine with a working width of 2140 mm and a maximum bending thickness of 1.7 mm, ideal for construction sites. This machine is designed for bending metal sheets, especially aluminum, with a strong steel frame and fully welded construction, ensuring high durability and easy bending. The working table is precisely manufactured using CNC machines, ensuring straight and accurate bends. Standard features include a rear metal support, front cutting stops, an angle gauge for precise bending, and a locking mechanism for bending multiple sheets with the same angle. Each machine comes with CE safety certification and warranty. The MTB 10-40 blacksmith manual pipe bender is an ideal choice for small workshops and garages. With a compact design, easy to control, and high mobility, the machine makes it easy to use. Equipped with a powerful hydraulic motor, the MTB 10-40 is capable of bending metal pipes with diameters from 19 mm to 114 mm and pipe thicknesses from 0.8 mm to 5.0 mm. The machine has many pressure settings, allowing flexible adjustment according to each type of material. The machine comes with an adjustment roller for square/rectangular pipes from 15 by 15 mm to 40 by 40 mm and can bend round pipes up to 38 mm. The automatic galvanizing plant uses a precise process to load the critical material into each bin. The loaded basket will be transferred to a sealed tank, where before being removed, the material surface will be cleaned by a centrifuge. The first basket in the system will be noticed at a specific speed and time. The baskets dipped into the tank will be moved into position, leaving no space for the new basket. After plating, the products will be transferred to the passivation tank and finally to the inspection and sorting belt. The process of bending square aluminum pipes by machine includes the following steps: cutting the pipe to the required size, lubricating the mold to set the bending machine, installing the pipe into the mold, bending the pipe to the set angle and radius, checking the quality, and completing the product. The machines provide versatile equipment for precision and ease of artistic metalworking. The SSB 3-coiler allows for easy rolling of 1/2 and 3/4 pieces of metal. The VDZ30 basket making attachment allows for the creation of decorative wrought iron baskets. The WZT24 hydraulic bender, equipped with a belly die, creates elegant curved designs. The STM5 motor unit and twister work seamlessly with the EAS3 head forging attachment to forge solid bars into tapered ends. The HPG2B embosser crimping square bars, embossing flat bars, and hammering tubes, embossing up to 20 feet in just 30 seconds, combining speed with craftsmanship. APK 240 hydraulic bending machine has a capacity of up to 240 tons, a maximum bending length of 6 meters, and precise control via electronic system. The machine is equipped with an advanced hydraulic controller, which optimizes the bending process. APK 180 hydraulic bending machine is capable of bending steel plates with a capacity of up to 180 tons and a maximum bending length of 4 meters. The machine is equipped with a precise hydraulic control system, providing high performance and long-term durability, suitable for projects requiring high precision. APK 550 hydraulic bending machine is a powerful equipment specialized in bending large steel shapes with high precision. The machine has a bending shaft diameter of up to 550 millimeters, bending moment of about 1,200 kN, and the ability to bend steel with high thickness and durability. Den metal flow forming and spinning machines with artificial intelligence. Automatic contouring of axes. Toolpath generator with AI. Automatic force control for error-free production. Den edge computing to bring AI to the machine. The new generation CNC tube bender, without head CC90, bends hollow tubes up to 180 degrees, with superior finish and speed. The machine-rolled steel process uses specialized rolling equipment, such as a rolling machine. The steel plate, or coil, is fed into the machine, where rollers adjust the radius and squeeze the steel into a circular or tube shape. The machine can adjust the speed and force of the roll to ensure accuracy. After the roll is finished, the steel coil is cut, inspected for quality, cooled, and re-welded by workers. Finally, it is inspected and shipped. The tube bending process uses press rollers to shape the tube to the desired angle with high precision. This method, usually done by cold bending, ensures a smooth surface and is widely used in industries. The Nargisa MC400 bender is made of steel, has 3 pull rolls, gear drive, and machined and straightened shafts. It can bend pipes up to 2 inches 1/2 inch, 63.5 millimeters. Making aluminum bells by spinning metal begins with selecting a thin sheet of aluminum. A spindle is prepared to fit the bells, which are usually round and tapered. The aluminum is mounted on a spindle, and a tool is used to shape the metal. As the rotation proceeds, the aluminum is gradually set into the bell. Once the desired shape is achieved, the material is cut, and the bell is polished to a smooth finish. This process allows for precision, making it ideal for producing high-quality aluminum in a cost-effective and efficient manner. The automatic bending machine, CNC, uses numerical control technology to perform bending of metal pipes or bars with high precision. The system automatically adjusts the rollers and bending dies according to the entered parameters, allowing bending of various shapes, increasing productivity and reducing errors. The SDMC 12000 gantry is equipped with a 4-axis CNC control system for precise and efficient operation. It features a Renishaw RTS cordless tool system and a 3D surface probe for enhanced measurement accuracy. It also features an auto-indexing right-angle head, advanced rails, and a 40-tool automatic tool changer. The T-slot table measures 11,989 millimeters by 2,200 millimeters and provides high-pressure coolant with a programmable airflow cooling system for the spindle. Additionally, it features Heidenhain scales on the X, Y, and Z axes for superior accuracy. Hot rolling is a common metalworking process that takes place at high temperatures. First, the metal billet is prepared and heated in a furnace to a temperature high enough to make the metal plastic. After heating, the billet is passed through a roughing roll system to reduce its thickness and give it a preliminary shape. Next, the billet is finely rolled through smaller rolls to achieve a more precise shape and size, creating products such as plates, coils, bars, or tubes. After rolling, the product is cooled through a water cooling system. Finally, the step is cutting into equal parts, checking for quality, and packing for shipping. Hot rolling allows for the processing of large billets, high productivity and cost savings. However, due to working at high temperatures, the product may not achieve the same precision and smooth surface as cold rolling. Nargasa's CC60 and CC90 CNC tube benders represent the cutting edge of metalworking technology, providing optimal solutions for industries such as renewable energy, marine, automotive, construction, furniture, and agriculture. With coreless tube bending technology, the CC60 and CC90 can process round, square, rectangular, or oval tubes, reaching a maximum bending angle of 180 degrees, suitable for a wide range of materials from carbon steel, stainless steel, aluminum to copper, with thicknesses ranging from thin, 1.5 millimeters, to thick, up to 10% of the tube diameter. The next project is to manufacture a metal chair frame based on the technical drawing which requires bending 4 angles: 30 degrees, 90 degrees, 90 degrees, and 30 degrees. On the CNC interface, the operator selects automatic mode, enters the tube parameters, and programs the bending angles, noting the stopper positions, for example, the end stopper at 530 millimeters, and the overall length of the part. The machine is adjusted by loosening the set screws at 0 and 90 degrees to ensure the correct stop point. The tube is clamped to the Play-Doh. The bending area is lubricated with Bend 8 special oil to reduce friction and protect the surface. The bending process is carried out sequentially at each corner, with each turn of the tube 90 degrees according to the drawing. The project to manufacture a revolving window for a Can-Am buggy requires high precision to create a closed frame. A cardboard template is used to determine the shape and bending angle, then the parameters are entered into the CNC system. The machine performs each bend according to the program, but to avoid collision with the stop at the end corner, the tube is removed before completing the closed loop. After bending, a 28 mm diameter round bar is inserted into the joint for additional strength. The frame is placed on the prototype to check the fit, then painted and assembled directly onto the vehicle. This project illustrates the mass production capabilities of the CC90, with a memory of up to 10,000 programs, allowing complex settings to be easily reused, ensuring consistency in production. The first project is the fabrication of a bicycle parking lot using a 20 mm diameter, 2 mm thick round steel tube on the CC90 CNC. The process begins with determining the tube development by measuring the tube center geometry with a wire, cutting the tube at a length of 645 mm and marking 2 bending positions. A 20 mm bending die is installed and secured with screws, and a suitable contraforma is mounted on a cart to clamp the tube. In the CNC system, the program is automatically initiated, the tube parameters are entered, two bending angles are set, 60 degrees and 120 degrees, and then the program is saved with a specific identifier. During execution, the tube is aligned so that the mark on the tube coincides with the mark on the mold. The machine automatically bends at 60 degrees, then the tube is rotated and bent again at 120 degrees. The result is two identical finished frames, demonstrating the CC90's ability to produce accurate and fast mass production. The final project is the fabrication of a swimming pool railing using 42.4 mm diameter stainless steel tube with a bending radius of 127.2 mm. The tube development was calculated based on the drawing, adding the straight sections 100.8 mm, 1070.28 mm, 596.44 mm, 570.28 mm, and the length of the bends, using the coefficient K equals 0.01745 multiplied by the bending radius and the difference between 180 degrees and the inside angle of each bend. The total tube length was 2,941.04 millimeters, with stops determined at 2,840.24 millimeters, 1,567.67 millimeters, and 887.99 millimeters. On the machine, the mold was installed, the strut, tirante, was fixed, the stops were set according to the calculation, and the counter mold was lubricated with Bend Aid oil. 3 bends were made consecutively, resulting in a railing with a crease-free inside surface and a perfectly round outside surface, meeting the strict aesthetic and technical requirements of outdoor applications. This project confirms the CC60 and CC90's ability to process sensitive materials, such as stainless steel, ensuring superior finishing. 4.0 technology is an important highlight of the CC60 and CC90, bringing outstanding efficiency in production. The CNC system with a 7-inch touchscreen, supporting more than 20 languages, allows programming up to 50 bending angles on a part, automatically adjusting elasticity, rotation speed, and notifying